This is episode 16 of the SOC Level 2 pathway of TryHackMe, and today we are continuing down our detection engineering module, and we're going to be talking about Sigma, which is a very important language when it comes down to writing rules for security information and event managers. So Sigma is one of those languages that kind of applies to everything. It's a universal language, so to speak, and this is a very, very useful tool for you to have as you go into SOC Level 2, security analysis, anything of the sort, because it's open source, it's used by everybody and anybody, and it's one of those things that it'll just apply to you in the rest of your career with every other tool that you use. So I'm actually very excited about this one. We've touched on Sigma a couple of times in the last previous rooms, but today's specific video is dedicated directly to Sigma, and we're going to be talking about its overview, what it is, how it works, how to write the rules, what the syntax is like, and all the different nitty-gritty details of the language so that you can become a Sigma master. And I'm very, very excited about it. My name is Hank Hackerson, and I'm your host for today. And to find more videos like this, or to learn about cybersecurity and pen testing and all the other good stuff, I do encourage that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And we have already the SOC Level 1 playlist on the channel. We have the pen testing playlist on the channel, and a lot of other good stuff, honestly. And I've gotten a lot of good feedback from it, so I think you'll get a lot of good value from it. So to find more videos like this, or to get more videos in the future, I do encourage that you like, subscribe, and turn on the notification bell. And if you're interested in advancing your knowledge, I do want to introduce you to Hackaholics Anonymous, which is our membership community on YouTube. And I honestly designed this with the intent of making it the premier group for security professionals and hackers. And there's 4 tiers to our perks. In every single tier, you actually get something in return for your contribution. So this is not something that we just say, hey, give us your money and thank you so much for being a supporter. You actually get perks like live streams and exclusive content and Python automations that apply to system administration, for pen testing, for cybersecurity analysis, and a lot of other amazing perks that honestly I've gotten really good feedback from already. And I think they're actually really good, valuable stuff, because there are other channels that are just saying, hey, give us $50 a month. Thank you so much for being a supporter. And I just didn't want to do it like that. So I wanted to actually give some real value in exchange. And I think you will get some really amazing value from the Hackaholics Anonymous community. So definitely check that out if you haven't already. And let me know what you think. If nothing else, we'd love to hear back from you. And hopefully we'll actually get to see you in our membership chats on Discord, and we'll get to see you in the membership community. Now, that being said, let's actually jump into our content for today, which is the Sigma room. All right, so as I already mentioned, Sigma is an open source generic signature language, and so it's used by people all over the industry. And there's actually a lot of already pre-established Sigma rules that have been written in YAML files that you can use for fine-tuning and kind of configuring your SIEM software to just make sure that it's, all-inclusive for your industry or anything of the sort. But today we're also going to talk about how to write your own very individual Sigma rules as well to configure and fine-tune and customize your SIEM software. The learning objectives are to just understand the language, to learn more about the writing syntax and converting it to various SIEM queries, navigating through the writing of the rules and various detections on Windows event logs, and practicing at some writing of the Sigma rules for an interactive case that we have later on coming up. These are the prerequisites for this room. I've actually created a video on every single one of these rooms. So if you have not gone through the security operations room, for example, I would recommend you go check that out just so you understand what that is. The Windows event logs, if you haven't gone through it, I would recommend going through that. The Sysmon room, if you haven't gone through it, or the Splunk basics and the investigating with elk basics, all of those things. If you haven't gone through those, I would highly recommend you go through those, because they're going to be supportive of the video that we're going through today. So you can go through today's video without going through those videos. I'm not going to say that you won't be able to learn, but I think you'll get much more comprehensive education if you actually go look at those videos as well. But you may just be a wild person, you know what I mean? You just want to kind of jump in the deep end and see how you handle things. So if that's you, then it's all good. We're about to go into the basic definition and kind of like the overview of Sigma, and then we're going to talk about the syntax and have some good fun stuff. All right, the reason why Sigma is so important is that there's a lot of information that comes in from a lot of different types of logs. And you have to build detection queries for individual logs from individual systems. And depending on what kind of environment you're in, or depending on what kind of software you're using, it's very difficult to create a standardized investigation approach, or a standardized approach to parsing through the logs and figuring out how to find signatures for different indicators of compromise and all of that. So the whole idea behind Sigma is to have this universal open source approach that applies to everything, and it bridges that gap, so to speak, so that you can use Sigma rules depending on, doesn't matter if you're using Splunk or if you're using ElkStack or Chronicle, you can use Sigma rules to customize and configure your queries and to kind of create this all-in-one type of an environment for finding indicators of compromise and the signatures that are associated with them. And that's where Sigma really kind of shines, and it really comes into play. It's open source, meaning that there's a lot of documentation on it. You can go find its GitHub repository. I'm gonna click on the link at some point today. And it was developed by Florian Roth. And if you've gone through any of the rooms or any of the videos that I've done on cyber threat intelligence, you should recognize this name. This guy is a legend in the cybersecurity community. And he's developed a lot of stuff. And this is actually something that he developed. And it's kind of similar to JSON, and because it's like a structured format, but it's specific for log files versus anything else. So it's a really great tool for log file analysis in a very similar way that Snort is used for network traffic and Yara is used for files in general. So it makes it easy to perform content matching based on collected logs, to raise threat alerts for analysts to investigate, and the log files are usually collected and stored inside of a SIEM or a database, and then Sigma allows you to find whatever you need out of those logs. And then I'll show you Uncoder in a little bit, because Uncoder is one of these like conversion translation type tools that we use to convert Sigma rule files into queries for various SIEM tools. So these are some of our use cases. You can make detection methods and signatures shareable alongside IOCs and Yara rules. You can write SIEM searches that avoid vendor lock-in. You can share the signatures with threat intelligence communities. And you can write custom detection rules for malicious behavior based on specific conditions. You need 3 things to make this work. You need the Sigma rule format, which is just a kind of like the general structured log description written in YAML. We'll talk about that in a little bit. You need some kind of a converter. And there are several converters that actually are written as Python scripts, but then there's also the service that we're going to talk about later, which is Uncoder. And then what happens is that you end up with the machine query that comes out as a query that will be used for a SIEM. So this is the GitHub repository, and inside of the GitHub repository you have all of these things, including the deprecated versions of Sigma, as well as documentation and rules and a lot of other things. And what's really nice about this is that if any of this doesn't make sense, or if some of these things aren't fully comprehensive, where you can't fully understand what's going on, you can go to something like Gemini and you can say, hey, I'm trying to figure this out about Sigma rules, can you help me? Or go to the Meta AI. Meta AI is also really powerful. Or, ChatGPT, which is kind of like the most popular one, the most famous one, because it was one of the first official ones that was launched. But you go through all of those, and it helps you understand everything that might be missing in the GitHub repository, for example. And this is the conveyor belt visual of it. So you have a Sigma rule that's written, it goes through the translator, and then it gets converted to Elasticsearch query, or a Carbon Black query, or a Google Chronicle query, or a Splunk query, so on and so forth. So that's really what it looks like and what it actually is. It's just basically an open source universal language that can standardize a lot of signature and IOC detection so that you can go ahead and use it for your individual software security information event manager. So let's talk about the syntax a little bit. The syntax is actually very important, and once you kind of understand the syntax, everything else starts to make sense. Okay, so there is this task file that we can download that is literally this. So this is what the task file looks like. And they've given us the field along with a commented description of what goes inside of the field. So that, the title is, the title of the rule. The ID would be the UUID generated from this for particular thing. For example, the status of it is the stage of what it is, the description of it, the person who wrote it. A lot of these things are not required. Some of them are absolutely required. So for example, the title is required, the log source is required, the detection is required. So these are the pieces that are absolutely required, and you need to have them inside of your rule context or rule description, syntax, whatever you want to call it. But a lot of these things are not required. They just make it a little bit more user friendly when you get into the SIEM software and trying to understand where the rule came from and what it does, so on and so forth. So it's written in the YAML language, which is a structured language. It's an object serialization language, and it's a substitute for something like JSON. So some things that you need to keep in mind is that YAML is case sensitive. Files should have a YML extension. Spaces are used for indentation and not tabs. So if you want to create a tab, you don't click on tab, you like do 2 spaces or 4 spaces, and now you have an indentation. Comments are attributed using the hashtag, as we just saw. Key value pairs are using the colon, and array elements are using the dash, and you'll see all of that in a little bit. And we of course have the YAML tutorials right here, which is just on the tutorials point website, and you can just search for YAML or just go to tutorialspoint.com, tutorialspoint.com/YAML, and then you'll get to the YAML page, and then you can use all of these different sidebar tabs to navigate to the specific section that you want to go to. So this is what the syntax looks like, and as I mentioned already, on the right, if you pay attention to it, there are required fields and then there are optional fields, and the title is required, the log source is required, detection is required, and the condition is required. These are absolutely necessary for the file to do what it's supposed to do. Everything else is optional, and it just makes it more user-friendly for somebody who's viewing it on the back end, or when the SIEM is about to try to ingest it to try to make sense of what the rule is and what it does. It can use the optional fields to help you with that. So YAML Sigma rules. The syntax defines various mandatory optional fields that go into it, and then we have the WMI event subscription rule to define the different syntax rules. So we have the title, which is the name the rules is based on. The ID is the UUID, as we already saw, and then you can also add references to the UUID to make it a little bit more related, making it easier to form relationships between detections. For example, derived, meaning that this rule has sprung from another rule. It was derived from another rule, which may still be active, so the other rule could still be active. Obsolete means that the listed rule is no longer being used. It's obsolete. Merged means that it's combined with other linked rules. Renamed means that it was previously named something else and we just named it to a new name that is operating under right now. And similar means that it points to corresponding rules, such as the indicating the same detection content applied to different log sources. So the same type of detection is just going to different log sources. Then you have the status. So is it stable, meaning it's in production environments and it's actually running? Is it a test, meaning that it passed the experimental phase? So experimental is one level lower than test. So experimental means that it's very generic and it's still being tested. It could lead to false results. Test means that it's gone through the experimental phase and now it's being tried to make sure that it's all good, and it may require some fine tuning. Then deprecated means that it's been replaced and it's no longer yielding any accurate results. The related field is used to create associations between this rule and the one that was just deprecated. And unsupported means that it's not usable in its current state and you shouldn't use it. And then we have the description, and it's basically a very brief description of what it does. They're saying that you can be as verbose as possible on the malicious activity that you intend to detect, but don't go crazy with long descriptions. So you can be detailed and you can explain the malicious activity that you're trying to detect, but don't lose your mind and write essays inside of the description, right? Couple of lines, couple of sentences, short paragraph, so on and so forth. But yeah, just keep that in mind. The log source. The log source could be narrowed down by product, category, service, and or definition. So for in this case, we have the product is Windows, and in the categories, the WMI event logs, right? So output of a particular product, example, Windows or Apache would be the product. The category would be the log files written by that product. So it could be Windows firewall logs or Windows antivirus logs, so on and so forth. Service is a subset of the logs from the selected product. So it could be the SSHD on Linux or security on Windows. So security logs from Windows, security so secure shell D, I forget what D stands for on that, but SSHD on Linux, for example. And then we have definition, so just describes the log source and any applied configurations. Then we have the detection. So this is one of the required fields. This is very, very important to understand. And we're going to go into this much deeper so you really understand what's going on. But this is the detection rule. So this is what triggers the rule, essentially. So under detection, you have usually, or all the time, there's something else under detection. It could be selection or it could be other things, and we'll talk about it a little bit. And then there's condition. So under detection, there's at least this, and then there's at least the condition. And in this case, the selection is all of these event IDs. So remember earlier it said an array could be a list by hyphens or by dashes, right? So this is an array of event IDs that are all of our selections. So if any of these is triggered, meaning the condition for this rule, for WMI event, the condition is that if any of this selection is triggered, then the detection is now triggered and we're going to get some kind of an alert, or we're going to find some kind of a result when we're going through our SIEM. So this is the big thing to understand, is that there's a detection section, which is mandatory. And under the detection, there could be several versions of selection, and or just one selection that has a bunch of things under it. And then the condition would be the selection or the whatever the other versions of this were. It'll make sense in a little bit because I'm going to show you examples of it. But this is mandatory. So the detection is mandatory. False positive, not necessarily mandatory, but it could be a list of known false positive outputs based on the log data, which would make it a little bit easier for somebody to understand. And then again, we'll go into examples of that in a little bit. And then we have the level. So this one's also important. So informational, low, medium, high, or critical. You should kind of already be familiar with these words. Informational is the lowest level alert that comes up. So it's not severe. It's just something to be aware of. A critical thing needs to be fixed immediately. It needs to be addressed right away. And then there's everything in between. So you need to understand that if the level of this particular rule, and you know, when you go and search for Sigma rules, other authors will have created the rule, and then they'll say, hey, the level for this rule is a high level rule. So if something gets detected under this rule, you need to pay attention to it right away. Don't go take lunch if you find it. You know what I mean? It's like, skip your lunch, take care of whatever needs to be handled, or report it to your supervisor. Do something immediately before doing anything else. And then the tags are usually very helpful to understand how the category of this thing goes. So it could be a CVE number from the database. It could be a MITRE attack framework, a TTP for the MITRE attack framework. A lot of these things are available in our predefined tags that are, again, under the GitHub Sigma tags. This has actually it's no longer tags, it's under Sigma specifications. So this is where the Sigma specifications are, and the tags would be listed under that. And so this is an example of the false positives. So excludes legitimate vetted use of WMI event subscription in the network. The level is medium, and these are the tags. So persistence under the MITRE tactic, and T1546003, the MITRE technique. Then we have search identifiers and condition expressions. So search identifiers and condition expressions. The detection section of the rule describes what you intend to search for. And it could either be a list or a map. So it's one of those two. And a list, so let's see, using lists, they'll be presented using strings with a logical OR operation. So it doesn't actually say OR, it just means that it's one of these options. So mainly they'll be listed using hyphens, for example, what we see here. So it says host application, so the field inside of the log data, there's a field for host application. The host application contains either this or this. That's what it means. If it's been separated like this, hyphen and a line, it means that either of these options, if either of those is inside of the host application field, this needs to go off. This rule needs to go off. And that's basically what you need to understand about this. And then we'll talk about these, I forget what I think they're called transformatives, these words right here. But basically the selection is saying that the host application field can contain PowerCat or PowerCat.ps1. And if it contains either of these two, then this detection rule needs to go off. That's what this is if it's operating as a list, right? If it's operating as a map, it's a key value pair. And a key value pair is a little bit, I'm not even going to say it's more complicated, it's just different, right? So the key matches up to a field in the log data, while the value presented is a string or numerical value to be searched for within the log. And it operates an AND operation. So maps follow an AND operation. This one follows an OR operation, meaning that it's either this or this. The map follows an AND operation, meaning, so in our case, the selection, the rule intends to get on the image, it ends with either of the values, and the command line contains either value listed. So for example, the image ends with /rm or /shred. So either of these two, right? Either of these two and either of these two. So previously we only had this or this. And so this still applies, right? So inside of the host application, it's either this or this. And in here, inside of this, it's either this or this, and it's either this or this, right? So both of those conditions have to actually be in place. Both of those conditions inside of our selection have to be in place for this rule to be detected, for this to actually be triggered. So this is what an array is, or a map, excuse me. This is what a map is. So this is a map, this is a list. Inside of this map, we have two lists. That's how you can think about it. A map can contain multiple lists, essentially. The list says this ends with either this or this. This contains either this or this. In order for this selection to operate, this and this have to be existent, and then the condition is met and our selection is now being detected. That's how it works. Then we have the transformation modifier. So this is what we were just talking about. It contains this, right? So command line contains this, and it could be at any point in there. All means that all of the listed pieces have to actually be present. Base 64 looks at the values that are encoded with base 64. Ends with means that whatever the string prior to this is, it ends with cmd.exe. Starts with means that whatever the string is, it starts with power. So it could be PowerShell, PowerShell.ps1, power.ps1, etc. So the asterisk is a wildcard character, and anything could come after that. Same thing here, anything could come before this. So that's what ends with means. It means that it ends with this, and then this starts with means that it starts with this, right? And then anything could be after that. And then you have the type modifiers, which the only thing that exists right now, which is supported by Elasticsearch queries specifically, are RE, which is the regular expressions, and regular expressions are extremely amazing and they're super useful. I would say it's more useful. I mean, they're inside of Sigma rules, so they literally apply to pretty much everything that we do. You can create regular expressions for Python scripts. You can use them in SIEM searches. You can obviously use them inside of Sigma rules, inside of YAML files. So regular expressions are really amazing. I created a video on it. It's actually, I think, one of the better videos on regular expressions, and it's very comprehensive. It teaches everything from beginning to end. So I would highly, highly recommend you go watch that. It's actually one of the more recent videos that came out on the channel. And I made it because we were getting so many references in all of the other rooms to using regular expressions, and I was like, okay, I have to do this. If I don't do this, I feel like I'm doing a disservice to the community. So now there's a regular expressions video. That's basically all I'm saying. So if you haven't seen it, if you don't know how they work, or if you want to kind of get a review on regex or any of those things, I would highly recommend you go and watch that video. For conditions, this is based on the name set for your detection, such as selection and filter, and it will determine the specification of the rule based on a selected expression. Some of the terms supported include the logical and or, one all, which is the all of the search identifier, and one all of them, and then not. So it's kind of confusing the way they've outlined this, but we can just look at examples for it to make sense. So where the detection seeks to look either for this tool, or this tool, and with either filter values this and this. So this is what this means, right? So we have the detection. Previous, we had detection, and then there was just one place for selection, and then under selection, there were multiple things. In this particular case, we have detection, and then there's a tools section, and it says it's either this, or this, or this. And then there's a filter section, and it's either this or this. And then our condition says we want tools and filter to be present. So something from this list and something from this list needs to be present in order for this detection rule to be triggered. And that's what this whole thing is trying to say right here, which is, it was very confusing. The first time I read it, I was like, dude, what are you guys talking about? Another example to showcase a combination of these conditional expressions can be seen in the exact extract below from the run once persistence registry event rule, where detection seeks to look for values on the map that start and end with various registries. This one's a little bit of a longer one, so don't get freaked out. The same syntax applies. So we have one detection. Under the detection, we have a selection. And under the selection, we have all of these things. Okay? Now, here's how this works. Since it's looking for two softwares to exclude, so filtering out Google Chrome and Microsoft Edge, it wants to exclude all the entries that have those software in them. So the first thing is the target object starts with this registry. Okay, it's a registry field or registry path. So our target object starts with this. We also have another target object that ends with stub path. So it's either of these, right? Then you have a filter for Chrome, and the details for the filter with Chrome could be either this path or it could be this path. So it starts with this path or it ends with this path, but in either case, these two are the filters for Chrome. And then we have a filter for Edge, very similar. So the detail starts with either of these two paths or it ends with this path. And then that's basically it. And actually, I'm sorry, this full path is the ends with portion for the filter for Edge. So you have two target objects, and then you have a filter for Chrome and a filter for Edge. And inside of the filter for Chrome, there's this. And then inside of filter for Edge, there's this. Now your condition is this. Selection, which is this piece right here. And then there is and not one of. So it has to have at least something from the selection and neither of these. So not one of filter underscore asterisks, which means filter Chrome or filter Edge. So as long as it has something from selection and not these filters, then this is going to be triggered. Hopefully that made sense. It will make sense, I think, at some point in the future, but this was a little bit more of a complicated one, but you can kind of see how it works. And then usually you can, if all else fails, just look for the way that things are tab organized. So if this was not shrunken the way that it looks right here, let me see if I can actually shrink this real quick, so just to show you. Yeah, there you go. This is actually perfect. So you can actually see the indentation perfectly because you have the detection, and then under detection you have selection. Under selection you have the targets, and then under the same line, so in the same indentation as selection, we have the filter for Chrome and the filter for Edge. and then inside of this filter there's those details, and inside of filter there's these details. So the indentation helps you figure out what is what and how things are separated. Previously, it kind of looked like everything was under selection, but it's not. So there's selection, and then this is in the same indentation, and this is in the same indentation, which is how you can say you can have selection and not one of these. So what these things, as long as these things are not included inside of our results, then our detection is going to be triggered. And that's basically how you can kind of guarantee that your rule works. So let me go back to my split view. I like this split view because when I zoom in using my mouse, this thing becomes much bigger and it kind of zooms in and it makes it much more legible. So I usually read with the split view. Okay, so first question was, which status level could lead to false results or be noisy, but could also identify interesting events? And that is the experimental level. And this was above all of these things where we went to here. So status levels right here. So the experimental level is very generic. It's being tested. It could lead to false results and interesting events. And then we have the other piece, which is rule detection comprises of two main elements, which is the search identifiers and the condition expressions. And then two data structures for search identifiers are lists and maps. I answered these right before I started recording this. I was already recording this, and then I found out that OBS wasn't actually recording the screen because it had froze, and the only thing that it was doing was recording my voice. And I was already like 45 minutes into the recording, and that wasn't fun. So I had to restart the whole thing, and now we are back to where I left off before I realized that OBS was frozen. So now we're going to look at some rule writing and conversions, and this is where it gets kind of fun and we actually start doing some stuff. So here we go. Okay, so here is where it gets pretty useful. It's a little bit, if you've never gone through anything like this, I've never gone through anything like this. Okay, so I'm speaking from personal experience. I know that this is useful, but I also know that as you're learning something new, it can be kind of overwhelming. So I'm going to take my time trying to explain this because, number one, I'm trying to understand it, but also in case you've never dealt with this before, I don't want it to seem overwhelming or scary to you. So we just want to do this correctly so that we fully understand it. So the reason why this is so important and why it's so useful is that you want to, you can find Sigma rules that have been written by other authors that can kind of resemble what's going on in your company or your job. But the best thing is for you to learn how to write them from scratch so that you can actually create something that is very, very unique to your particular case. And this is what we're going to be talking about right now. So in our particular case, we're going to be writing a Sigma rule, but then we're going to convert it to Kibana, and then we're going to use a variety of tools to convert it. And the scenario is this, right? So there's something called AnyDesk, which is a remote tool that is actually a legitimate tool. And when you download it and install it, it runs a variety of commands, and these are the commands that it runs. And then when you look at it, just from first glance, if you know anything about pen testing or security, when you see the cmd.exe, that's like, oh, they're pulling up the command line. And if a hacker gets the download file of AnyDesk and does a phishing email, and it looks like it's a legitimate email from AnyDesk, and it involves the installation or the update file for AnyDesk or something like that, and inside of this list of commands, the attacker just puts a few of his own cmd.exe commands, they can do some shady things. And this is why it's important to first understand what the actual process looks like when you want to run something, and then you create something like rules that can catch your potential attacker. So in this possible case, I think this is actually the malicious version of it, because I noticed right here where they created a user old administrator, and they added that user, and then they added them to the administrators group, And then they even added a registry for that person inside of the special accounts registry. So I think this is actually the malicious version of all the commands that's been kind of embedded into the regular sets of versions. So we have the analysis of the intelligence. So you have the source URL that marks the download for the software page. So we have the source URL, download AnyDesk from AnyDesk.exe, so that's all good. The destination file is where you have a destination directory for the download, and this is marked by the file variable, which is this piece right here. So that part also still looks good. And then you have the installation command. Now this is the part where it gets kind of interesting. So you see that there's a various instances of cnb.exe being used to install and set a password by the script. Set a user and password by a script. From this, we can pick out the installation, like install starts with an silent. Other essential pieces are that the adversary, so this was the bad code. So the adversary persistence, they want to maintain access. That's what persistence means, is that they persist and they stay in the system. And to be able to do that, they created a username by the name of old administrator, and they gave themselves elevated privileges to run other tasks, and then they added themselves to the registry called special accounts. So with this information, now we can create a rule to detect when the installation has taken place. So the identification part is pretty simple. So AnyDesk installation is the title, the status is experimental, description is AnyDesk remote desktop installation, can be blah, 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 blah. The log source is going to be the process creation log source. So as indicated from the Intel, Windows devices would be our targeted device. Windows event log and sysmon provide events such as process creation and file creation. So process creation is an actual inherent event that is inside of event log and sysmon. So these are actual events that have their event IDs, so on and so forth, and that's their tag, is process_creation. Our case focuses on the creation of an installation process, therefore listing the log source category as process creation. Then you have the product being Windows. Now for detection and description, I would say this is probably the most important part, is the detection portion of this thing. So yeah, and they said it, this is the essential part. The information derived from the Intel will define what we need to detect. For the AnyDesk installation, we noted that the installation commands would be used by the adversary. They contain install and starts with win. And then we can therefore write the search identifiers as below with the modifiers contains and all to indicate that the rule will match all of those values. We can include the searching for the current directory where the commands will also be executed from, which is program data AnyDesk. So the selection is this: command line contains, so inside of the command line field contains all of these. So both of these have to show up. If all was not included here, it would be either this or this. But since we added all to the end of this specific line, that means both of these have to be present. So command line contains all of these, and then the directory also have to contain this specific piece, and both of these have to be present. Remember, this was a list, this is a map. In a list, unless you say all, if this wasn't here, right? In a list, it would be either this or this. But we put all, which means that both of these have to be present. And then in a map, both of these have to be present, which makes our entire selection. So the condition is the selection is this whole spiel right there, and then that would trigger our detection to go through. And then we have some metadata rules that we need to add to this. For example, the false positive. So if there's a legitimate deployment of AnyDesk, because it is a legitimate software, so if there's a legitimate deployment of AnyDesk, that's a false positive. But if there is not a legitimate, if it is actually somebody that got a command line and they created a user for administrator and they added themselves to special accounts, that is a high level urgency, severity kind of a situation, and you need to address that right away. This is the reference for it, which is it's a twitter.com So I wonder if this still even works, because Twitter got changed to X. So let's see if this even works now. Oh, it does. Yeah, okay. So it does look like it's still here. The DFIR report, X.com underground initial actions, yada 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 yada. So okay, cool. This actually does work. And then we have the tags, which is the attack, command and control, and then these are the MITRE tags for, what does they say? Tactics and technique. So this is the tactic, kind of command and control, and T1219 is the technique. So now converting the rule. So you have the full rule and the full file. I'm gonna create it so that you can also see what that looks like. So we have the full rule and the full file, but now it's in a YAML Sigma file. So you need to convert it so that it can be read by what we're using, which I believe it was Kibana. So we're using Kibana in our situation. So we have to convert it into something that's readable by Kibana. And you can do that from one of two sources. SIGMAC is a Python tool, but it has been deprecated by the end of 2022, and it was turned into Sigma CLI. However, a copy of SIGMAC is available on our attack box, and I'll try to see if I can use it for whatever situation. And it does look like this. So if you look at the help menu, it has the target system that you want to turn your file into. So it could be Chronicle, it could be Kibana, it could be Splunk, it could be any of these things, right? So then you have the actual file itself, and it converts the Sigma rule into a SIEM signature. The main options are T, which sets the targeted SIEM backend that you want for your whatever software you're using. C is the configuration file used for the conversions. So in this case, it would be actually the name of the file that you created. And then the backend option allows you to pass a backend configuration or individual modification that dictate alert options for the SIEM environment. For example, in Elastic, we can specify specific field properties to be our primary keyword field to be searched against, such as fields that end with keyword or security, like these fields. So this is the example here. So we're inside of this and we ran it, and then we ran T for ESQS, which is going to be, I don't know what it is, but whatever that is. And then C is going to be our configuration file, the YAML file, which is right here. And then the backend option is the keyword field dot keyword, and then another backend option, which is the analyzed subfield name, which is dot security. And then once you run it, I think this is actually when it finally runs, it gives you the piece, and then now it has the responses here. We can find more information for SIGMAC documentation and convert AnyDesk installation rule to Splunk alert as shown below. So this is the SIGMAC. T, it's been turned into Splunk. C is the Splunk Windows configuration file on the YAML, and then that's it. And it turns it into your AnyDesk configuration file for Splunk. But what we're gonna use is the Uncoder, which is an online service, which is actually very user-friendly. You don't need to run any Python files, and you can just copy and paste, and it'll create it for you based on the platform that you got. So first, what we gotta do is we gotta create the Sigma file. Once we create the Sigma file, we can then turn it into a Splunk query, or Kibana, I'm sorry, because we're using Kibana. So convert the AnyDesk installation we've written through this task to Elastic query and use it to analyze the log data from the launched machine on the Kibana dashboard. Take note that with the new version of Uncoder, the Elastic query will be produced in Lucene. Therefore, change the settings to be able to do the Kibana query accurately. And that's it. To be aware that the converted query may not all work verbatim as converted from tools. This is due to the processing of regex characters, and you may be required to adjust the queries, especially around escaped blank space and varied properties. For example, for this exercise, you have to remove the asterisk characters from the result and only escape the colon in the folder path in the directory slashes. So we will get there once we get there. The first thing that I got to do is, number one, I'm just going to pull up my Kibana instance. And then the second thing I got to do is I got to actually create that YAML file with all of these details for this spiel that we got over here. So first, let's go to our Kibana instance. All right, cool. There's that. And now I'm going to open up Terminal, and I want to go to my Sigma rule file, which is going to be in rooms, I think. Yeah, there it is. So we're gonna do nano sigma rule file, and here it is. So we gotta go piece by piece. I'm just gonna kind of fast forward through this whole process just to make it a little bit easier, but I will go ahead and write all of these things in here, because unfortunately you can't like select all and then replace it inside of nano like that. There is some kind of a text editor inside of Linux, but I don't know, there's something about writing everything inside of nano and the command line that seems super hacker, like it seems very legit. So I'm gonna do it inside of nano, and we'll be right back. Okay, I think we're good. Level is high. Actually, there is something that I'm missing, which is our references. I'm not going to put that link for the references, but I will actually put a couple of more spaces here. Okay, there we go. Now I think we're good. Now I think everything should be copacetic, as they say. So hopefully we're all good. We're going to write this, exit out. And now we have our Sigma rule. So what we can do is try to convert it to Splunk using the Python sigmac file. So let's see how that's going to work. Or I could just, I guess, copy the whole thing and go to uncoder. Let me do that actually, because I feel like that would be probably faster. So we're gonna, how can I highlight this whole thing? Okay, there's that. Go here, paste that. Okay, perfect. There we go. And then it automatically detected that it was Sigma. And then what we're trying to do is we're going to go to Elastic Stack, right? Or Elastic Alert. And it's trying to do, okay, so it needs to be Elastic Alert. Oh, I see. So they're saying, okay, I got it. So on Uncoder, it's going to be automatically in Lucene. And we got to change the settings on Kibana to be able to use Lucene accurately. Okay, so there we go. So this is fine. So Elastic Alert, we're going to translate it, and there we go. This is what it looks like over here. This is our rule, so it should be pretty, I mean, straightforward really. So now it says, beware that the converted queries may not work verbatim as converted from the tools. This is due to the processing of regex characters, the backslash and the asterisk, and you may be required to adjust the queries, especially around the escaped blank space and buried properties. For example, you have to remove the asterisk characters from the result and only escape the colon in the folder path and the directory slashes. So let's see. First and foremost, what is the tool that's used to convert Sigma? That is sigmac. At what time was the AnyDesk installation event created? And so this is what we're going to actually run on our Kibana instance. So it says, for the Lucene query, you may have to remove the current directory proportion or portion, as this is not a tagged property on this version of Elk. So right here, where do we have current directory? Right here, current directory. So we may have to remove this, and so this is our overall query here, which is this piece right here. So I'm going to copy this piece, and we're going to go to Kibana, and we're already in our winlogb index, which is the only thing I think that we actually are going to be using in our particular situation. So let's just run it. Let's see what it looks like. So we're going to turn that so it can be Lucene, and we're going to run this, and let's see if it works. All right, so on first load, when you actually load it, it just goes the last 30 days. And I just clicked on this piece on the side right here, and for a relative, I changed it from 1 month, which was the previous thing right here. It said 1 month ago. I changed it to 4 years ago because I had no idea what the date range was going to be. And then I got one event. This literally, with this query right here, we only get one hit that shows up out of all of our logs. And when you go to the process executable right here and look at the value, it says desktop AnyDesk. So I know that's probably the one event that we are looking for. And now we're looking for the timestamp, which is, in this particular case, what do they want? They want month, day, year, hour, minute, and second. So we want to go here. We got month, day, year, hour, minute, and second. So we're going to take this whole piece and copy that. Let's see. Boom. Let me see if that works. That does work. Look at that. Now, what version of AnyDesk was installed? So now we want to go and look at this whole piece right here. So just open this thing and see what information we can find. All right, so the first version that I see is this 1.12.0. I'm just going to test this out, see if this actually works. I don't know if this is actually it. It is not it. So what does the hint say? It says look at the available version fields. Okay, that's what I'm looking at. I'm looking at the version fields. Is there something on the left right here that says version? Agent version? That could be it. So 8.23. That could be our answer. So let's do copy that. Agent version. That is not the answer. So let me see. What other version field do we have here? Process PE file version. That could be it. 7.0, because I know it's not OS version for a fact. So let's trust process PE file. Hey, process PE file version is the answer, baby. Let's go. Okay, cool. So we got that answer, and we are still good, and the recording is still recording. Okay, very good. All right, so now let's go to SecOps Decisions. Okay, SecOps is short for security operations, and there are decisions to be made in security operations. So threat and log investigations may flow in different directions depending on factors such as the SIEM backend, log sources, and process flows established within the organizations. Same thing applies to Sigma rules. And for example, a Sigma CLI tool or uncoder would be essential to the detection investigations. You may encounter instances where the tools produce slightly different conversion outputs from the same rule and may not entirely match up with your backend configuration. So let's, for example, look at the change mode suspicious directory Linux rule, which is something that's been developed by the Sigma community. So we have, this is the rule for change mode suspicious directory, and specifically you have the detection that says if the image ends with chmod, the command line contains any of these, then this is supposed to be triggered. And that's basically it, right? That's the rule in a nutshell. Starting in SigMac, we set our target backend to Elastic Query using the ESQS. So that's what ESQS stands for, Elastic Query. And follow the selecting the preferred configuration option. After that, set the rule from the directory and obtain our output, which is a query that matches the process using the field names, image, and command line, with options that point to various directory files where it would be suspicious to find the change mode chmod command to begin with. So this is it. This is what it ran, and then it gave us the specific query. So this full thing is the query, from what I understand. And then we have on the other side what we used. On the other side of using the uncoder, the rule conversion produces a query that matches based on the field names, process executable, and process command line. So in this case, it did image keyword and command line keyword. And it gave us, this is very much so a regular expression pattern. So if you don't know what that is, this is very much a regular expression pattern. And in this case, this is also a regular expression pattern. And so process executable was the keyword that I searched for, as well as the process command line. So despite the similarities in the output, you would end up deciding the best outcome for your configuration and considering any regex used to escape any special characters, which you need to go and reference the regex video to understand what it means to escape a special character, to be able to use a special character, so on and so forth. So a lot of these things, the backslashes and the forward slashes, I believe the backslash is the escaping. Yeah, backslash is escaping and forward slash is like the literal thing. So he's escaping, meaning that when you do this, you're allowing for yourself to use this as a literal forward slash, because if you don't, in regular expressions, the forward slash is the beginning of a regex pattern and the end of a regex pattern. So if you want it to actually be a literal forward slash, you have to escape it using the backslash. Same thing with this. You do escape with the backslash, and then now it's forward slash chmod literally, and that's what regex is going to search for. So that's, it may sound confusing and you might have no idea what the hell I just said, which is why I would recommend going and watching the regex video. But that's basically it. That was the entire section that we just went through. They're just letting you know that you need to know which one of these patterns that was generated applies to your environment more closely, and you would only know that if you actually work in some kind of an environment that requires you to create Sigma rules. If you're just working based on theory, you're like, okay, well, now I know that in the future I can use these different tools, and one of them is going to give me one output, the other one's going to give me another one, and I'm going to have to figure out which one is which and what to use in whatever situation. So that's kind of the whole purpose of this entire task, is to just let you know, hey, you use your discernment, use your best judgment, and try to figure out which one applies to you most. So now we're going to go to our practical scenario to test the knowledge that we just gained about our Sigma rules and hopefully make a good Sigma rule and come up with the answers for, look at all these questions. Lovely. Okay, beautiful. All right, so here we go. Let's go into the practical. All right, so here is the scenario. Our organization, Aurora, has recently been experiencing unusual activities on some machines in the network. Amongst them, the IT manager noted that an unknown entity created some scheduled tasks on one of the machines and that ransomware activity was also recorded. The SOC manager has approached you to find ways of identifying these activities from the logs collected on the environment. It would be best if you used Sigma rules to set your detection parameters and perform the search queries through the Kibana dashboard. To complete the task, you will require 2 Sigma rules processed into Elasticsearch to query for the scheduled task and the ransomware events. Below are tips to construct a good rule. For the scheduled task, understand that it is a process creation event. The rules detection variable should contain image and command line arguments. You may choose to exclude system accounts from the query. For the ransomware activity, you'll look for a created file ending with txt, and the file creation process would be run via CMD. Change the default time window on Kibana from the default last 30 days to the last year to ensure that it encompasses 2022. So that part's fine. So we're creating 2 rules. One of them is for the scheduled task, the other one's for the ransomware activity. And as it says, we're doing a process creation event. Variables should contain image and command line arguments, so on and so forth. So what I'm going to do is I'm going to take this this file that I got here, and I'm going to drag it off screen into my other window so I could just reference it. And let me make sure that my recording is still working. Okay, great. The recording's still working. Okay, so we are going to create one for the scheduled task first. And then from there, we'll see how many of these questions go. And then to detect ransomware, what log source category. So, and then we go to ransomware at the last. So the first 3 questions are for scheduled task, and the second 4 questions are for the ransomware. All right, so let's see what our hint is in our case. Okay, that's pretty useless. Okay, here we go. Let's see what we can do. Okay, so the first thing that we actually had to find, and it doesn't really involve any results that we got from the Sigma rule, is to find the actual scheduled task executable inside of the Windows environment. So it's basically the executable that runs scheduled tasks, and it's a SC tasks executable. So this is the actual executable inside of Windows that runs scheduled tasks, and then you would have your scheduled tasks inside a configuration file, and then this executable is the piece, the image, so to speak, that runs whatever the executable is. So Now we know that this is going to be the image. So right here, right? So the image and command line argument. So this is going to be the piece in our image that we're going to use for our selection under the detection. And then after that, we need to also use some command line arguments that will be the creation of a scheduled task. So essentially it's create scheduled tasks. So hold on, I need to just double check and make sure that that's the case. Yeah, there you go. So this is actually it. So this is the command line, right? So I just asked, hey, what would be the command line? A command that would create a scheduled task using SC tasks. And so this is it, SC tasks, create, and that would be the task name and whatever. So these are the two things that have to be inside of the command line. So we just know that for a fact. So all right, so now we got our couple of pieces. So let's go create our little rule here that we can potentially use for uncoder to convert for us, and then from there we can mess with it. I could actually even do it over here probably. So let's see what we can find. Okay, so as you just saw, I basically modified the previous rule that we had over here, and this portion, pretty irrelevant. You can name it whatever you want, really. The log source stayed exactly the same because we were using a process creation log source, as it said over here. So this is a process creation event. So we just kept it the same thing, process creation for Windows. This is the piece that is the most important. So the selection, we needed to give something for the image field, and that was going to be the scheduled tasks.exe. And then also the command line contains all of these things. So it has to contain both of those. Schedule task and create has to be inside of the command line. And then our filter, so the filter, if you remember, was the thing that would remove or not include, right? And so we want to avoid including the system user based on what we got. So you may choose to exclude the system account from the query, and this is the actual username for the system, is the NT authority system. And that's it. Our condition is going to be selection and not filter, and hopefully this will actually create a rule for us. So let me translate this, and it did create something, so it got something over here. So let me see. Okay, so I think this is actually it. You may notice that there are 2 backslashes here. And if you remember, based on what I said a few minutes ago, 1 backslash inside of regular expressions, especially in the Kibana query language or Splunk's query language, to be able to use it as a literal backslash, you need to escape it. So this 2 represents just 1 backslash as a literal backslash. And then same thing right here where you do a backslash dot, because a dot can represent a wildcard character. So you have to do a backslash to have a literal dot here. There's also a version of this where you can just put this inside of quotations instead of having the double backslashes or escape backslash. But I think this should work. So this part should be fine. And I mean, we're literally about to find out if it is going to work. So we're going to copy this whole query, and let's see what we can find here. We're going to go use this whole query. All right, so that version didn't work, so I'm gonna I created a little version that has instead of the like excessive backslashes, we're gonna use the quotations. So let's see if that works. Okay, cool, that one did work. Okay, so I think it was actually the Splunk query language. Maybe Lucene doesn't work like that, but the Splunk query language was one of those things where you had to do a backslash to escape it, so you could use a literal backslash, but essentially the command itself is the same. It's just, or the query, excuse me, the query is the same. It's just that we, instead of using the double backslashes, we did the quotations to be able to escape it. And so now we have this piece right here. So what's the question that we're trying to answer? It says, what's the name of the scheduled task that was created? So let's try to find that real quick. Okay, so here we go. Process command line was the field. So I opened it up using this little button right here, and then it brought right here, and then inside of the search bar I just typed in command. And as we saw with our Gemini help right here, it tells us, right? So TN and then the task name. So it's what we're looking for after TN is the value. So when you go over here, after TN, which stands for task name, we have spawn. So spawn is our task name. There we go. And what time is it meant to run? So let's see if we can find that in the same situation here. Right here. So schedule task at 2010. So create once, TN spawn, and then at 2010 is when it's supposed to run. And kaboom. Okay, cool. Awesome. Now we're going to go to Uncoder and just modify the previous rule that we had, because it seems to be the easiest to just do it inside of this place. So I'm just going to modify all of this and create it for our new situation. So let's see what hints we have over here. Okay, so I asked Gemini for some help here, and interestingly enough, it gave me the answer, but it's like not giving it to me the way that I thought. So basically, I was like, if I'm trying to detect ransomware in Windows and I'm writing a Sigma rule, I know the product would be Windows, but what would be the category? And right here it says the category would be ransomware, but then when you go over here under the log source, it says category file creation. So this is what I was looking for. So product is going to be Windows, the category is going to be file creation. So that's the first piece that I know I want to do. So let me do this piece real quick, and then we're going to modify these pieces. Okay, and so now we got to modify a few of these. So I'm going to remove the filter because I don't need that anymore. The image in this particular case, I believe is going to be the command line image. And the command itself, we no longer need to use because we're not using a command line, but we are looking for a file name. So the target file name is going to end with .txt based on what we were just told. So I think that's it for the selection. So the image is going to be the CMD. So let's just verify this, right? File creation process would run via CMD. So that would be our image. We're looking for a created file that ends with TXT. So file creation that ends with TXT. And that's it, right? So selection is this image. Target file name ends with TXT. And our condition is actually just going to be this selection. So there's no filter to deal with. And that's it. I want to say that's the entire rule. So, okay, so let's translate this guy. And now we have this piece right here. And it did turn it again into this thing. And I feel like this is not going to be detected. I'm going to run it, but I think that's not going to be detected because last time it wasn't detected for the other one. So let's just run it for the hell of it. Why not? Yeah, nothing shows up. So I'm going to just real quick replace these things with... Oh, and I got to remove that one. So let's go. Interesting. Okay, there we go. Okay. I mean, that's so weird. Okay, but all right, fine. The text, the process executable text has cmd.exe in it. And the file path text has *.txt, meaning anything that comes before .txt, essentially. So it has to be a file path text with txt in it, and a file executable text process executable text has to have cmd in it, and we got one result right here. So the specific thing, let's see, what are the questions here? To detect ransomware activity, what log source category would be appropriate for the Sigma rule? And that was the file event that we just found thanks to our friend Gemini. And what is the name of the created file? Okay, so let's go find the name of the created file. Okay, cool. Just searching for name inside of our results right here. Got file name right there, and it's yourfiles.txt. Pretty sure that's the file name, so let's try that out. Cool. What was the event code associated with the activity? So what we're going to do, we're going to search for event, and event code right there is 11. So we're going to try that boy out. Very cool. And then what were the contents of the created ransomware file? So now we want to actually look at the contents. I wonder how we can find that. I'm going to do this. I'm going to actually use the file name as the content, or there's the search parameter. And there's nothing here. So what if we did your files.txt? Nothing there either. So that didn't work. Let's see. Oh, you know what? It's because I will actually, now I get it. All right, I get it. Because I was looking inside of this event for the contents of this thing, and there was nothing there. So if I just search for this file, okay, there we go. Okay, cool. Now we have 4 events associated with that file name, and I just need to be able to find the contents of the thing. So how do we do this? Let me see. I'm gonna do some funky stuff. I'm gonna go into my fields here, and let me see what I can find here. Okay, cool. So inside of this search bar right here, for all of our interesting fields, our available fields, I typed in command, and we have a process command line and process parent command line. When you click on process command line, we get 2 results right here. And this one is interesting because it has an echo, and I wonder, let me see if I could, I want to see these values here. So we'll just add this to our search. Let's see what we get. There we go. There's 1 file, and then one event. And then we're going to open it up, and then we're going to type in command here. Boom. Okay, there it is. And so there we go. CMD echo desktop da 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 da. So echo inside. So this thing right here, this little arrow that points to the right, means that it's going to write this piece inside of the yourfiles.txt. So this is the path of the output, essentially. When you do echo whatever the command is, this arrow, the path that goes afterwards is where the content is going into. And so this is the name of our file, is the txt file. And so this is what's being echoed into the txt file. So that should be our answer. Yeah, buddy. Look at that. What did the hint say? It says search for an event with the file name as part of the command. Oh, okay. That was in there. That was one of our hints. There we go. We got it. We got the practical scenario. That was not that bad. That was okay. The creation of the Sigma rules were the big piece for this. So, being able to know what category that you want to create for your Sigma rule, and then these pieces right here, this is, to me, this is the hardest part to try to figure out, and I had to use Gemini to help me. So this is what I'm saying. I'm learning how to do this, and I want to make sure that I also kind of do it right, to be able to teach you that. And the image itself is the executable, the process that is being searched for, and then you have a target file name, which could be the field that you're searching for. You have, in the previous example, what was it in the previous example? It was the command line. So inside of the command line, the command was schedule task and create. So we were looking for those 2 keywords inside of the command line. So I'm going to copy and paste the previous one that we had, just so you can kind of, I can show you both of them, right? So what did I have here? I'll just do this, and then we'll paste this here. So there we go. This is, let's paste these things. Okay, so this is kind of what it was like for the previous one, right? So these pieces, pretty much bullshit, irrelevant, have nothing to do with it. Log source was important, so it's the process creation category for Windows, and then under that you have the detection portion for our selection. There was the image itself, which is again the process, the executable, very similar to this one. In this case, it was the command line executable. In this one, it was the scheduled task executable that schedules the tasks or runs scheduled tasks. And then the command line itself, so the command that was ran to generate the scheduled task was scheduled tasks create, and then task name, and then so on and so forth. So we're looking for this specific executable as well as the command line words or strings that would imply that there was a new task being created. And then we want to filter the system user. So we want to say that we don't want anything to show up from the system user, because the system user would most likely create all of these things legitimately, and that would all be noise for us, and it would be irrelevant to us. So this one actually had a filter. And so the filter was the user would be this guy. And then so when you create your condition, you're saying that you want the selection and not this. So I want everything that shows up for this, except don't show me anything that has to do with the user system. Okay? That, just reading it out loud for myself. I'm literally reading it out loud just to kind of reconfirm everything that we just went through. That was this one. That was this whole piece right here. That was the first search for the schedule task. And then for the ransomware, again, these pieces kind of irrelevant. The log source is important because we have the file creation category for Windows. And then this one was simpler. The selection, there was only a selection. There was no filter associated with it. And the image was the command line image, CMD. And they kind of told us this, right? So they gave us these pieces right here. The file creation process would be run with this. And for this one, they didn't give us the process that we would be using for, but they did mention schedule tasks. So for the schedule task, understand that it's a process creation event. So what would be the process that would create schedule tasks? That's kind of the thought process you go to try to find that. And in this case, they gave us the process, which was cmd.exe. And then they also said that we need to look for file names that end with .txt. So that's where the target file name ends with .txt comes from. And then you create your condition, which is the selection. That's it. And this one was much simpler than the first rule. And then you saw that we got our results. And then we just kind of went through the results to try to find the answers for the questions. So you can use Gemini to get you the general Sigma rule. This is what I'm saying. It's like, your job is to use the tools that you have at your disposal to create these things quickly. Even if you know how to do them by hand and you know how to do them manually, if you know how to give instructions to a tool like Gemini and say, hey, listen, I'm making a Sigma rule. This is what the rule is for, and this is what it does, and this is what it's searching for, Gemini can write it for you because it's job. That's the job that it's supposed to do. You just need to know how to communicate with a tool like that. And that in itself is a skill set. So, take it for what you will. Take it with a grain of salt, so to speak. But you can do this manually. I think you should learn how to do this manually. It's important to understand what you're searching for, what the parameters are, what the a list is, what a map is. It's important to understand all of that stuff. And then once you understand all of that stuff, to make your life a little bit easier, to do things faster, to make sure that you don't make any mistakes, you can use a tool like Gemini to either create it for you or to just confirm what it actually needs to be, right? And so in this particular case, it said it like log source, the category is file creation, the product is going to be Windows, and these would be the fields or whatever. And it says field name or file name ends with this, file size end with that. And it didn't really create our entire Sigma rule for us. It just kind of gave us some examples of what it would be. In this situation, they kind of gave us what the specific parameters are. And I was able to just combine the two sets of instructions essentially, along with the rest of the instructions that they gave us inside of this room. So that is it for our Sigma room. And this was very cool. And so, we have a conclusion piece right here that has this. Oh, this is actually cool. This little cheat sheet. I'm probably going to, Sigma cheat sheet. I'm probably going to distribute it to the community. I'm going to include it as a part of this whole video. So that would be nice. That would be a nice little piece to include as the whole video, as kind of like an extra download for the whole video. So I'm excited about this path. This was very useful for me. I learned a lot. I'm going to most likely review this room multiple times just to make sure I understand exactly what just happened and what went on. And hopefully you also got a lot of value out of it too. If you found this video useful, or if you've gotten any value from this channel, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that we drop something. And you know what? Maybe even drop a comment. The comment section is very live. I get a lot of questions from the comment section, and I actually love hearing from our members in our community because it kind of helps me feel the pulse of the community to understand what people want to see, what they want to hear, and what type of content should be created. And I am very responsive, as you can tell. I go back and forth with it just to make sure that everybody gets what they need. And if there's a really good question, I even create a video from that question. So this is one of those things that, again, I'm just super passionate about, and I would love to hear from you. You know, just say hi, say thanks if you want, whatever, like ask a question if you got it. It just depends on what you're looking for and depends on what kind of value you're looking for. But in either case, I would love to hear from you. And if you did find value from this channel, if you find value from this video, I would very much love it if you would give us a like, if you would subscribe to the channel, and of course turn on that notification bell so that you get notified the next time that a video comes out. And I would be remiss if I did not mention the Hackaholics Anonymous membership community. It will be, and it is the premier YouTube community for security professionals and hackers. There are many perks that are associated with it for each individual tier, and I take this very seriously. I very much love this community. I do everything that I possibly can to make sure that there's value inside of the community. And for people who are actual paid members of our Hackaholics Anonymous group, if you speak with them, you will get the testimonial that they actually are getting the values from it. And you know, as a shout out, if you are a part of the Hackaholics Anonymous community and you're hearing this right now, please drop a comment below and mention that you are part of the Hackaholics community and that you actually are getting value from it. I'm probably going to start saying that from now on, just to make sure that we get people to shout us out and just let us know that they are getting value from it, just so we can get more people inside of that membership community. That being said, that is a wrap for this video. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. I hope you found value from this video. I will see you in the next one later.